Okay, so this lesson will continue dealing with functions, but now instead of evaluating functions and plotting points on a graph, we're going to look at graphs of functions and extract points and use them to represent values of functions. So here's our first example. We see a picture on the right hand of the screen. This is our graph of f of x. And they're asking us to evaluate f of x at different values of x. So we see here, this is when x is -1. They want to know f of -1. So we say, well, there's -1 on the x-axis. We trace that all the way up till we hit the graph, and we see there's a point at y equal to 5. So we can say that f of -1 is equal to 5. And they're asking us to do this for these others as well. So when you're asked to evaluate a function using its graph, you want to first determine its input value, go to the axis, which is the input axis. In our case, it's the x-axis, and we trace it up till we hit the graph, and that's the y value, and that represents the value of the function. And then f of 1, you find it, you trace it up, and you find the corresponding y value. F of 2.5, so it's halfway between 2 and 3, and we want to keep looking halfway between 2 and 3 and say, where does it eventually hit the graph? And it looks like around 4 is our approximate value. Notice there's an approximate sign, and it looks like it's approximately equal to 4. Question 5 says, express your answers above as a set of ordered pairs for f of x. So we have -1 comma 5, 0 comma 1, 1 comma 3, and 2.5 comma 4. So here's our second example, g of x, and notice that we have this weird graph that's zigzagging all around. It's not smooth like what we're used to seeing. This is known as a piecewise graph. We will get into more detail of piecewise functions as we learn deeper into this unit. But for now, we see that it's defined differently on this domain here from -5 to -2, and then it's defined differently again and defined differently again. And that's what a piecewise function does. It has a bunch of different definitions over different intervals of the domain. For now, we just want to be able to say, okay, this graph is called g of x. We see the g on its name, and we want to evaluate the y values that go with the corresponding x values. So when it asks what is g of -3, we find -3, trace it up, and we see it's +3. For question 2, it says what's g of -1 plus 3? So we find the value for x equal to -1 goes up to 2. So that means that this is 2 plus 3, and the answer is 5. For number 3, it's asking what is g of 4 plus g of a? So we find that 4 is at 1, so this would be 1 plus g of a. Because we have no way to determine g of a, they didn't give us a definition for the function, we just write it simply as 1 plus g of a. And for number 4, it's asking what is g of 2 minus 3? Notice there's an approximate sign, and that's because we're estimating what g of 2 is. It looks like it's approximately 1/2. So -2.5. So that's the end of this presentation. Now you know how to look at the graph of a function and use it to evaluate the function for different values of x.